Myself, Armanisha, I am explaining about bonding and madelung constant. Bonds. Atoms in a solid are held together by interatomic forces which are responsible for bonding atoms are called bonds. Bonds are of attractive and repulsive force. Bonds are classified into two types: primary bond and secondary bond. Primary bond. Primary bonds are interatomic bonds and they are classified into three types: ionic bond, covalent bond, and metallic bond. Ionic bond. Bond formed by transfer of electrons between two atoms is called ionic bonds. This bond occurs between electropositive and electronegative atoms. This bond is found in NaCl, KOH, etc. Properties of ionic bonds. Ionic crystals possess high melting and boiling points. All ionic solids possesses crystalline structure. These solids are hard and brittle. Ionic bonds are non-directional. Covalent bond. Bond formed by sharing of electrons between two or more similar or dissimilar atoms is called covalent bond. This bond is possible whenever such sharing result in decreasing of potential energy. This bond is present in hydrogen, nitrogen, diamond, etc. Properties of covalent bonds. These solids have low melting and boiling points are compared to those of ionic solids. Covalent crystals of different materials have differences in their properties. Covalent compounds can be solids, liquids, or gases. Covalent bond is directional. Metallic bond. The bond which results from the sharing of variable number of electrons by variable number of atoms is called metallic bond. This bond is present in metals. This can be considered as unsaturated covalent bond. This bond is found in sodium, copper, gold, aluminium, silver, etc. Properties of metallic bonds. Metallic crystals have high degree of crystal symmetry. Metallic bonds are weak, so the melting and boiling points of metallic crystals are lower than that of ionic and covalent compounds. Metallic bonds holds the atoms together in metals and their alloys. Metallic bond is non-directional. Secondary bonds. Secondary bonds are intermolecular bonds and they are classified into two types: hydrogen and van der Waals bonds. Hydrogen bond. This bond is special type of dipole bond. Bond between molecules having permanent electric dipoles between similar molecules. Each bonding molecule have one end as a hydrogen atom converted into a positive ion by a strongly electronegative adjacent atom in the same molecule. This bond is found in water molecules. In water, the positively charged hydrogen end of one water molecule is attracted to negatively charged oxygen end of another molecule, resulting in hydrogen bond. van der Waals bonds. This bond has weak bonding force that results in mutual interaction between molecules or atoms. This weak force is due to unsymmetrical electrical charges in electrically natural atoms or molecules. This interactive force is very small. Properties of van der Waals bonds. Van der Waals bonds are non-directional. Van der Waals bonding is weaker than the hydrogen bonding. Van der Waals bonded solids have low melting points. They are good insulator of electricity as no valence electrons are available. Madelung constant. The Madelung constant is used in determining the electrostatic potential of a single ion in a crystal by approximating the ions by point charges. It is named after Erwin Madelung, a German physicist. It is named as after Erwin Madelung, a German physicist. Calculate Madelung constant for NaCl. For NaCl lattice, sodium chloride crystal consists of Na plus and Cl minus ions. Now consider sodium ion Na plus located at the center of the cell as shown in the figure. Positive sodium ion Na is surrounded by 6 neighboring negative ions Cl minus at a distance 12 nearest positive sodium ion Na at a distance of R0 root 2, 8 negative chlorine ion Cl at a distance of R0 root 3 and 6 positive sodium ion Na plus at a distance of 2 or not, etc. There will be repulsive potential between Na plus and Na plus ions and attractive potential between Na plus and Cl minus ions. The attractive potential energy between central sodium ion of Na plus and 6 chlorine ions of Cl minus is equal to minus q square by 4 pi E naught R naught into 6 of 6. Q is the charge of electron. The repulsive potential energy between central sodium ion and Na plus and 12 sodium ions Na at a distance of R0 root 2 is equal to q square by 4 pi E naught R naught into 12 by root 2. The Madelung constant alpha m is given as alpha m is equal to sigma 1 by r ij by r. Thank you.